Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Mir Shah. I am a lecturer in Department of Technology, Sarad University of Science and Information Technology, Peshawar. As I am teaching you the subject Design of Hydraulic Structure, today is your lecture number 21. In lecture number 21, we will continue about the topic cross drainage works. We have already studied about what is cross drainage work, their necessity, and some of the types were already studied. In this lecture, we will study about the rest of the types of the cross drainage works. So, coming to the topic, the other type of cross drainage work is super passage. The super passage is just opposite to the aqueduct. In this case, the bed level of the drainage is above the full supply level of the canal. The drainage is taken through a rectangular or trapezoidal trough of the channel, which is constructed on the deck supported by piers. As you can see in the figure, it is just opposite to the aqueduct. As in case of aqueduct, the stream is flowing below, while the canal is flowing on the above the stream, but in this case the canal is flowing below the stream and the stream is flowing above the canal. The section of the drainage trough depends on the high flood discharge. Also, a freeboard of about 1.5 meter should be provided for safety purposes. The trough should be constructed of reinforced cement concrete. Also, the bed and banks of the canal below the drainage trough should be protected by boulders pitching or lining with concrete slabs. And the foundation of the piers will be the same as in case of the aqueduct. So, basically, in super passage, all of the criteria about the cross drainage work is the same. Related to the construction of the structure, but it is just opposite to the aqueduct, as in case of, as already discussed, as in case of the aqueduct, the canal is flowing above and the stream is flowing below. In this case, the stream is flowing above while the canal is flowing below the stream, while the rest of the structure and everything is the same as in the aqueduct case. Next type is the siphon super passage. It is also just opposite to the siphon aqueduct. In this case, the canal passes below the drainage trough. As you can see in the figure, the canal is passing below the drainage. The drainage or the stream is flowing above the canal. The section of the trough is designed according to the high flood discharge. This section is known as the trough, and it is designed according to the high flood discharge. The bed of the canal is depressed below the bottom level of the drainage trough by providing a sloping apron on both sides of the crossing. This is the full supply level of the canal, while this is the level of the highest flood level. These are the banks of the canal, and the canal passes below the stream level. The sloping apron may be constructed with stone pitching or concrete slabs. Also, the section of the canal below the trough is constructed with cement concrete in the form of tunnel, which act as a siphon. So that's why it is called as a siphon super passage. The cut-off holes are provided on upstream and downstream side of the sloping apron, and the other components are same as in case of the siphon aqueduct. So basically it is just opposite to the siphon aqueduct. All the structures are similar to the siphon aqueduct. The only difference is that the canal passes below the drainage trough. Next type is the level crossing. The level crossing is an arrangement provided to regulate the flow of water through the drainage and the canal when they cross each other approximately at the same bed level. So when the canal and the drainage crosses each other at the same level, the structure constructed are known as the level crossing structures. In this case, we have a crust wall constructed on the upstream side. Also, we have a canal regulator on the downstream side of the canal and a river regulator on the downstream side of the river. The level crossing consists of the following components. The crust wall is provided across the drainage just at the upstream side of the crossing point, and the top level of this crust wall is kept at the full supply level of the canal. Drainage regulator is provided across the drainage just at the downstream side of the crossing point. The regulator consists of adjustable shutters at different times. The canal regulator is provided across the canal just at the downstream side of the crossing point. This regulator also consists of adjustable shutters at different times. So basically the water is flowing in the river water is stopped with the help of the crust wall, and this crust wall is in the level of the full supply level of the canal. So with the help of this river regulator, the flow is regulated in the river, and also with the help of this canal regulator, the flow is regulated with the help of this canal regulator in the canal. So through these regulators, the flow is controlled in the rivers. The other type is the inlet and outlet. In the crossing of small drainage with small channel, no hydraulic structure is constructed. Simple openings are provided for the flow of water in their respective directions, and this arrangement is known as inlet and outlet. In this system, an inlet is provided in the channel bank simply by open cut, and the drainage water is allowed to join the channel. At the point of the inlet and outlet, the beds of the bank of the drainage are protected by stone pitching. So at this point, this is known as the inlet, and at the inlet point, the stream water or drainage water is allowed to join with the canal water, and up to this point they move in the canal, and at this point a small channel is provided which takes the water from the canal again to the stream. So in this way both the canal and the stream water are regulated, or you can say supplied to the canal and stream. So both can be used at the same time, and this is known as the inlet and outlet, and are known as the cross drainage works. Also, this is the end of today's lecture.